Right now, above your head, the sun is firing off explosions more powerful than billions of nuclear bombs, and one of them could, in theory, unplug the modern world. Not slowly, not politely, but in minutes. Here's the uncomfortable question. Could a single solar flare destroy the internet? Before you dismiss this as science fiction, remember this. In 1859, a massive solar storm, known as the Carrington event, slammed into Earth. Telegraph systems sparked, operators were shocked, and some lines continued transmitting even after being disconnected from power. And that was in a world without satellites, without Wi-Fi, without global data centers. Now imagine that same level of solar fury hitting today's hyper-connected civilization. First, let's interrupt a common misconception. A solar flare alone does not directly burn the internet. The real danger comes from something called a coronal mass ejection, a CME. A solar flare is an intense burst of radiation. A CME is a massive cloud of magnetized plasma hurled into space. When a CME is aimed at Earth and strong enough, it can trigger a geomagnetic storm. And geomagnetic storms are where things get serious. When charged particles from the sun collide with Earth's magnetic field, they distort it. That distortion induces electric currents in long conductors on the ground, especially power lines. These are called geomagnetically induced currents. Long story short, the sun can overload transformers. And here's the controversial part most people don't realize. The internet doesn't live in the cloud. It lives on the power grid. Data centers, server farms, undersea cable repeaters, cellular towers, they all rely on electricity. No power, no internet. So could a solar flare destroy the internet? Not instantly, but it could cripple the electrical infrastructure that keeps it alive. Let's look at real data. In March 1989, a geomagnetic storm caused by a CME collapsed Quebec's power grid in just 90 seconds. 6 million people lost power for 9 hours. Transformers in New Jersey were damaged. This wasn't hypothetical. It happened. In July 2012, Earth narrowly missed a Carrington-level CME. NASA later reported that if it had struck, the economic damage could have reached trillions of dollars globally, with recovery times measured in years. Here's why recovery is so slow. High-voltage transformers are not easy to replace. They can weigh up to 400 tons, cost millions of dollars, and often take 12 to 24 months to manufacture and deliver. They are custom-built and not stockpiled in large numbers. Now imagine dozens or hundreds of these failing simultaneously across continents. The power grid goes down. Large regions lose electricity for weeks or months. Data centers switch to backup generators, but generators need fuel. Fuel requires supply chains. Supply chains require power and communication. You see the cascade. Now let's talk about the internet's physical backbone. Over 95% of international data travels through submarine fiber optic cables laid across ocean floors. These cables themselves use light to transmit data and are generally resistant to geomagnetic interference. That sounds reassuring until you learn about repeaters. Every 50 to 100 kilometers along those cables are powered repeaters that amplify the optical signal. These repeaters depend on electricity supplied from landing stations connected to terrestrial power grids. If coastal power infrastructure is damaged by geomagnetic storms, those repeaters could fail. And repairing undersea cables is not like rebooting a router. It involves specialized ships, precise location work, and can take weeks per break. Here's another pattern interrupt. Satellites are not the internet's main backbone, but they are critical. A severe solar storm can damage satellites, disrupt GPS signals, interfere with aviation, and affect timing systems. GPS timing is essential for financial transactions, telecommunications synchronization, and power grid management. Even a small timing error can ripple through banking systems and mobile networks. During strong solar events, satellites may be placed in safe mode. In extreme cases, they can suffer permanent damage. So could a solar flare destroy the internet? Destroy forever? Highly unlikely. Disrupt massively? Absolutely possible. The probability matters too. According to research published in recent years, the estimated chance of a Carrington-level geomagnetic storm hitting Earth in any given decade is roughly 1 to 2%. That sounds small until you compare it to other global risks we actively prepare for. Airlines plan for far rarer failures. Governments insure against less probable disasters. Yet space weather preparedness often receives a fraction of the attention. Here's where the debate gets interesting. Some experts argue that modern grids are more resilient than in 1859 or even 1989. Grid operators now monitor space weather forecasts from agencies like NOAA's Space Weather Prediction Center. Satellites, such as NASA's SCAVR, sit about 1.5 million kilometers from Earth at the L1 Lagrange point, giving us roughly 15 to 60 minutes of warning before a CME impact. That warning can allow operators to temporarily shut down vulnerable equipment, reduce loads, and protect transformers. But critics argue the grid is still dangerously exposed. Much of the infrastructure in North America and Europe is decades old. Not all transformers are shielded against geomagnetically induced currents, and developing nations may have even fewer protections in place. So which is it? Overhyped fear or underestimated threat? The honest answer is somewhere in between. A solar storm would not erase the internet from existence. The data would still exist in hardened storage systems. Fiber cables wouldn't melt, but prolonged regional blackouts could fragment connectivity. Some countries might recover quickly. Others could remain offline for extended periods. Think less digital apocalypse. Think more digital ice age in affected regions. And the economic consequences would be staggering. Modern finance, logistics, healthcare, and communication depend on constant connectivity. Even a few days of widespread outage would cost billions. Months could reshape global markets. Now let's zoom out. Solar activity follows an approximately 11-year cycle. We are currently in solar cycle 25, which began in 2019 and is projected to peak around 2024 to 2025. Increased sunspot activity raises the likelihood of flares and CMEs. Most will miss Earth. Some will graze us. A direct, extreme hit remains rare, but not impossible. Here's something most people don't realize. Smaller geomagnetic storms happen regularly. They create beautiful auroras. They occasionally disrupt high-frequency radio communications. Airlines sometimes reroute polar flights during strong events to avoid radiation exposure and communication blackouts. So the sun already affects our technology. The only question is scale. Could we harden the grid? Yes. Solutions include installing series capacitors to block geomagnetically induced currents, improving transformer design, developing rapid replacement programs, and enhancing space weather forecasting. Some countries are investing in these measures, but global implementation is uneven. And here's the deeper controversy. We spend enormous resources defending against threats from Earth, storms, earthquakes, cyber attacks, but comparatively little preparing for a storm from space, despite clear historical evidence that it has happened before. The Carrington event is not theoretical. It's historical fact. If it happened today, in a world with over 5 billion internet users, over 10,000 active satellites, and deeply interconnected power grids, the consequences would scale accordingly. But let's ground this in realism. The internet was designed to be decentralized. Data routes dynamically. If one path fails, traffic can reroute. This resilience makes total global collapse unlikely. However, decentralization cannot overcome prolonged loss of electricity across wide regions. No power, no routers, no cooling systems, no signal amplification. In the end, the biggest vulnerability isn't the cables. It's the grid. So could a solar flare destroy the internet? Not permanently, but a powerful coronal mass ejection could severely disrupt electrical infrastructure, damage satellites, fragment global connectivity, and trigger economic shockwaves that last months or even years. The sun doesn't need to invade us. It just needs to burp in our direction. And the unsettling truth, it has done it before. If this made you see the sky differently, follow for more science that connects cosmic events to your everyday life. Now I want to know, do you think governments are taking the threat of extreme space weather seriously enough? Or are we dangerously underprepared for the next big solar storm?